Hey everyone, and welcome back to another explainer. Today we're turning our attention to Chapter 6, the architecture of artificial intelligence, and we are heavily focusing on learning and ethics. You can basically think of this explainer as your ultimate interactive exam prep. We're going to take the source material, break down the core concepts, and then actually test your knowledge in real time. So if you've got a test coming up, you are absolutely in the right place. Grab a mental notepad because we are getting straight to work.
Okay, here's the game plan for today. We're covering 1. Types of machine learning, 2. AI bias, 3. Multiple choice practice, 4. Identifying ML types, and finally, 5. Critical thinking. And just so you know exactly what to expect, your upcoming exam is going to consist of exactly 6 multiple choice questions, 4 machine learning type identification questions, and 2 critical thinking questions. And the good news? We're practicing all of them today.
All right, let's kick things off with Section 1, Types of Machine Learning.
Okay, let's dive right into this. Lesson 1 of your text focuses on the foundational ways AI actually learns, because, it's not magic, it's just very specific, structured algorithms. First up, we have supervised learning. I want you to literally think of this as learning with a teacher. The AI is fed data that already has the answers attached to it. We call these labeled examples. So, for instance, if you want an AI to filter your inbox, you feed it thousands of emails that are explicitly labeled as either spam or not spam. The AI studies these labeled examples, learns the patterns, and then tests itself on new data. We see this all the time out in the real world with things like email filtering, medical diagnoses, and credit approvals.
Now, within supervised learning, there are 2 distinct subcategories you absolutely need to know. The first is classification. This is when the AI predicts specific categories. Think of a simple yes or no, or categorizing an image as an apple, orange, or banana. That spam filter we just talked about, perfect example of classification. The second type is regression. Regression doesn't predict categories at all. It predicts continuous numbers. Imagine an AI forecasting future sales for a business, or predicting the exact selling price of a house based on its square footage. So just remember, classification is for categories, regression is for numbers.
And that brings us to unsupervised learning. Just like the name suggests, this is learning without a teacher. There are 0 labeled examples, and no correct answers are ever given to the AI. Instead, the AI is handed a massive pile of raw data and told, hey, go find the hidden patterns on your own. The primary method it uses to do this is called clustering. This simply means grouping similar things together. For example, an e-commerce site might use clustering for customer segmentation. They group buyers with similar habits together to recommend products, completely without human labels telling them who is who.
The third main type is reinforcement learning. And honestly, this brilliantly illustrates how machines learn through sheer trial and error. The AI, which we sometimes call the agent, takes an action. Then the environment responds. If the action was good, the AI gets a reward. If it was bad, it gets a penalty. Then it learns from that and repeats the process millions of times. This is the exact framework they use to train self-driving cars to stay in their lanes, or how they teach Boston Dynamics robots how to walk.
Moving right along to Section 2, AI bias and ethics.
So that covers how AI learns. But what happens when the data it learns from is flawed? Well, that's where AI bias comes in. This happens when an AI system is unfair and treats different groups differently. And usually it's entirely unintentional. But the real-world impact is massive. Bias can unfairly deny people loans, jobs, or even healthcare. So where does it come from? The source is almost always skewed training data. If the data we feed it reflects historical human prejudices, the AI is just going to learn and amplify those prejudices. The fix, therefore, is pretty straightforward in theory, even if it's hard in practice. We absolutely must use diverse training data that equally represents all demographic groups.
Okay, Section 3, Multiple Choice Practice. Let's see how this all builds together.
Let's move to the live exam simulation, starting with the multiple choice section. These are the exact 6 questions you need to master, in order. Here are questions 1 and 2. Question 1. Which type of machine learning uses labeled examples? Is it A, unsupervised, B, reinforcement, C, supervised, or D, deep learning? Question 2. Predicting categories like spam or not spam is called A, regression, B, classification, C, clustering, or D, reinforcement. I'm going to pause for a few seconds here, read the options on your screen, and mentally lock in your answers.
All right, let's see how you did. For question 1, the answer is C, supervised learning.
Remember, the teacher in supervised learning provides those labels. It's definitely not unsupervised because that has 0 labels, and reinforcement uses rewards and penalties, not labels. For question 2, predicting specific categories like spam or not spam is B, classification. Regression would be predicting numbers, not categories, and clustering groups unlabeled data, which clearly doesn't fit here.
Let's keep the momentum going. Question 3. Grouping similar customers by behavior is an example of A, classification, B, regression, C, clustering, or D, prediction. Question 4. What is AI bias? A, AI being too expensive. B, AI treating different groups unfairly. C, AI running slowly. Or D, AI using too much data. Take a moment to ponder your choices before we move forward.
So the crucial point for question 3 is that grouping behavior without explicit labels is C, clustering. It's not classification or regression, because remember, those require a teacher to provide labeled data. And for question 4, AI bias is fundamentally about fairness. So the answer is B, AI treating different groups unfairly. It's not about the speed of the computer, the cost, or data limits. It's strictly about equitable outcomes out there in the real world.
All right, here are your final 2 multiple-choice questions. Question 5. Where does AI bias usually come from? A, computer viruses. B, skewed or biased training data. C, fast internet. Or D, new computers. Question 6. How can we fix AI bias? A, use less data. B, use diverse training data that includes all groups. C, make AI faster. Or D, remove all labels. Take 2 seconds to lock these in.
The answer to question 5 is B, skewed or biased training data. It has nothing to do with the computer virus, internet speed, or hardware issues. It's all about the bad data going in. Because of that, the answer to question 6 has to be B, use diverse training data that includes all groups. Using less data or making the AI faster or just removing labels entirely won't solve a representation problem. You fix skewed data with better, more representative data.
Next up, Section 4, Identifying Machine Learning Types.
Great job on the multiple choice. Now we transition to the next major structural part of your exam, identifying machine learning types. You're going to be given a scenario, and you must identify if it's regression, classification, clustering, or reinforcement. Here are your 4 specific scenarios from the text. 1. An email system trained on 50,000 emails labeled as spam or not spam. 2. A robot learns to walk by getting a reward when balanced and a penalty when it falls. 3. A music app observes skips and replays with no labels and groups songs. 4. A dataset of 10,000 records labeled diabetic or not diabetic predicts diabetes in new patients. Take a deep breath, review these scenarios, and try to assign a machine learning type to each one.
Now, what's really interesting about this slide is how the context clues give the exact answer away. Scenario 1 has explicit labels for categories, so it's classification. Scenario 2 uses rewards and penalties, making it definitively reinforcement learning. Scenario 3 specifically notes there are no labels given and it groups songs. That grouping behavior is clustering. Finally, Scenario 4 uses labeled data to predict a yes or no category of diabetic or not, so it is also classification.
Finally, Section 5, Critical Thinking.
We have reached the final phase of your exam prep, synthesizing what you've learned to actually tackle real-world critical thinking problems. Here is your first scenario straight from the text. A hiring AI was trained mostly on resumes from male candidates. For your exam, you need to be able to answer 2 things here. What bias might it develop, and what is the real-world impact? Take a moment to formulate your answer.
Okay, your answer should hit these key points. The AI would likely favor male applicants and reject equally qualified female candidates. The real-world impact there? Unfair hiring discrimination. And the root cause is simply that the training data was heavily skewed, vastly underrepresenting women. It is a classic textbook case of bad data leading directly to a biased real-world outcome.
Let's look at the second critical thinking scenario. A face recognition system works well on light-skinned faces, but poorly on dark-skinned faces. Again, 2 parts to your answer. What likely caused this, and how exactly can it be fixed? Take a second to formulate your thoughts.
If you noted that the cause was skewed data, you are absolutely spot on. The training dataset likely contained mostly light-skinned faces, so the AI literally never properly learned to recognize darker skin tones. The fix, which you must be able to state clearly on the exam, is to train the system on a diverse dataset that includes all skin tones equally.
I want to leave you with this final provocative question from your textbook to wrap up our explainer.
Why can AI bias be dangerous, even when it's totally unintentional? The answer is that the real-world impact, denying someone a loan, a job, or proper healthcare, is harmful regardless of the intent. Unintentional bias still causes real-world discrimination. Understanding that is absolutely the key to mastering this material. Review these concepts, practice these specific questions we went over today, and you are going to absolutely ace that exam. Thanks for joining me on this explainer, and keep learning.